In this video, we are going to look at the science paper 1 for 2019 internal. Now we'll just look at some questions from section B. So let's begin. Figure B1.1 is a graph showing how the velocity of a car changed when the driver applied brakes upon seeing a head of cattle crossing the road ahead. Then we can see that we have the graph slanting down. So whenever we have the graph slanting down, the acceleration is always negative. So the negative acceleration indicates that the speed of the car or a moving object is decreasing. Now, from the question, use the information on the graph to calculate the first question, the deceleration of the car between A and B. So our A is here, then our B is here. So this is our B. Now, let's look at where this line is starting from. So this line is starting from A. So point A is our initial. So this is where we are going to get the initial velocity. Then our B, this will be our final velocity here. Now let's apply the formula. So acceleration is equal to final minus u over t. Then the final velocity, we are getting it from point B, so we need to go in the y-axis. So the final velocity will have 2 minus the initial is where this line is starting, so we can see that it's 12. So we have 12 over t. Now the time taken from point A to B, we can see that here somewhere between 4 and 6. So we can see that here we have 5. So 12 minus 12 will give us negative 10 over 5. So if we divide 5 into negative 10, will give us 2 meters per second squared. So this is our deceleration or negative acceleration. Okay, so now we move on to question B. Distance moved by the car in the 10 seconds. So let's see if we can have the picture. So this is the distance that we want here. Now let's analyze this one. So there are so many ways in which you can write the distance, but as for me, I'm going to break this region into two regions. So the one I'm going to shade with green, so this one will end here. So we can see that here, this in green will give us a right angle triangle. Then this one in red here, this one in red will give us the rectangle. So this is what we are going to use. So let's begin. So distance is equal to, first we'll find for the right angle triangle. So it's half b multiplied by h. So if this is our distance, then the distance, the base is here. This distance is our base. So we can see that the base, we said the base for this triangle is from here up to here, which is 5. Then the height is from this point up to here. So it's a difference between 12 and 2. So we can now subtract 12 minus 2 is 10, or we can say 2, 4, 6, 8, 10. So our height is 10. So distance is equal to half, 2 into 2 is 1, 2 into 10 will give us 5. So 5 times 5 will give us 25 meters. So this is the distance for the first part. Now we need to find this distance here. So this is giving us a shape of a rectangle. So distance for a rectangle is L times B. So the L is this longest distance here. Then our B will be this distance here. Okay, so let's look at the L. So the L is from 0 up to 10 here. So we have the length of 10. Then the breadth is from here up to here, which is we'll get it from the y-axis, is just 2. So if we multiply 10 times 2 will give us 20. So our final answer is, now we need to find to add the two distances. So 25 meters plus 20 meters, this will give us 45 meters. So this is how we can answer. It's one of the way you can answer, but there are so many. You can break it into maybe a trapezium. So it depends on the shapes that you are able to see clearly, and also earlier before the other shapes. So for question C, we want the average speed of the car. So average is equal to total distance over total time taken. So the total distance, we've calculated it. So the total distance, we are saying it's 45 meters over the total time taken is 10 seconds. So if we divide the 10 into 45 will give us 4.5 meters per second. So this is how we can answer this question. Okay, so now we move on to question 2. Figure B2.1 shows a device designed to compress crushed material for science project. So we can see that we have the diagram here, then we have this lever beam, the piston. So the piston is movable. As we try to push this lever down, then we are forcing the material to be crushed. So that's a picture that we have here. So this piston is pushing down. As long as the force is applied here, the piston is pushing down, forcing the material to crush. Now, the first thing, whenever you are dealing with moment, first you need to look at where the pivot is. So here the hinge indicates the pivot. So the pivot is the point where the moment is turning. Now, after we've studied this diagram, so let's look at the first question here. State one condition necessary for a body to maintain equilibrium. So for this to be at equilibrium, the two moments, there is this force that is pushing the lever up, and also there is this force that is pushing the lever down. So we have two moments, which is the anti-clockwise moment and the clockwise moment. So for the body to maintain its equilibrium, the two moments must be equal. So we can say the clockwise moment must be equal to anti-clockwise moment. So this is the condition that must be met for it to maintain the equilibrium. Now let's move on to question B. Calculate the moment of the 50 newtons force about the hinge. So we know that the moment is equal to force multiplied by distance. So we have been given the force is 50 newtons. Now what is the distance? So let's look at this. So we have the 50 newtons from here up to, 55 up to here, and also from here up to here we have 10. Then are we going to use the 10 or 55, or are we supposed to add? So the point here is the distance. The distance is taken from the point of action, from the point where the force is applied to the pivot. So since the pivot is here, the distance that we are going to use is this one. So we are going to add 10 centimeters and 55 centimeters. Now, whenever you are finding the moment, the distance should be in meters. So we need to convert it. So first, let's find the total distance. So it's 55 centimeters plus 10 centimeters, which will give us 65 centimeters. Now let's convert this centimeter into meters. So we know that 1 meter is equal to 100 centimeters. So cent means 100. So here we are going to put 65 centimeters. Here x will cross multiply. So 100 centimeters times x is 100 centimeters x. Then 65 centimeters, then meter. We divide by 100 centimeters, also here by 100 centimeters. So if we cancel, our x is centimeter and centimeter cancels. So 100 into 65 will give us 0.65 meters. So maybe to simplify, we are saying 1 meter is equal to 100 centimeters. So if we want to convert from meter to centimeter, you multiply by 100. The reverse is also true for from centimeter to meter. So here you divide by 100. So whenever you have a distance in meters, in centimeters, to convert it into meters, you need to divide by 100. So now we can find our moment. So moment is equal to, our force is 50 newtons times the distance 0.65 newtons. So if we multiply 50 times 65, 50 times 0.65, getting 32.5 Newton meters. So this is our moment. Okay, so now we move on to question C. Calculate the upward force which the crushed material exerts on the piston to keep the beam in equilibrium. Okay, so let's see what we can see here. So the upward force is like pushing this, so it is moving in this direction here. Then the downward, this force of 50 is, so we can see the two moments that we have here. So this one is clockwise, then this one is anti-clockwise. So we are going to use the principle for something to balance under equilibrium. So let's look at what we can say. So here we are going to say moment 1 is equal to moment 2. So moment is equal to force times distance. So here we are going to have force 1 times distance 1 is equal to force 2 times distance 2. Now we'll consider the upward as moment 1. So moment 1 we are solving for force 1 times the distance. Now for this moment we'll consider this distance from here up to here, so it's just 10. Now 10 divided by 100 because we want to convert into meters, so will give us 0.1. Then force 2 we have it is 50 times the distance was 0.65. So if we multiply this will give us 0.1. F1 is equal to, here we have 32.5. we calculated these ones. Then you divide by 0.1. Also here 0.1. So let's look at force 1 is equal to, so 32.5 divided by 0.1. So I'm getting 325 newtons as our force 2. Now for in terms of the force, since we are not going to find the moment, in terms of the force we can also find the same answer but just by using the actual distance. So let's say we have force 1 times the distance 1 is equal to force 2 times the distance 2. So force 1 is what we are solving. Distance 1, let's just take it as 10 centimeters. Then force 2 we know is 50. So say 50 times 65 centimeters. So 10 centimeters times F, we have 10 centimeters F1. Then let's say 50 times 65, I'm getting 3,250. So let's divide by 10. Also here we divide by 10. So if I cancel, I can see that we are getting the same number, 325 newtons. So the point here is, if you are calculating moment, if the question is find moment, make sure the distance is in meters. But if you are calculating distance 1 or distance 2, force 1 or force 2, you can use distance in meters or in centimeters. The answers will always be the same.